In our next unit, we will be studying this fabulous U-shape called a parabola. And similar to lines that we've gotten very familiar with, parabolas can end up steeper or flatter. They can turn one direction or face the other. And we're going to learn a little bit today about how we might figure out what a particular parabola looks like based off of the equation. Now, parabolas are built off of the parent function, or the original function, f of x is equal to x squared. So basically what we're doing is we're taking the x value and we're squaring it, which has an interesting result because as you think about it, squaring a number increases much faster than just adding to it. So if I go one step over from this turning point, 1 squared takes me up 1. And if I go over 2 steps, 2 squared goes up 1, 2, 3, 4. So you're going to see those square numbers, 3 squared, 9, and so on and so forth, just like in the table here. And that pattern will appear even if we shift this U-shape, the parabola, around the coordinate plane. Now, what if I wanted to change the shape of the parabola? So here are some different graphs to compare. We're going to expand our parent function and we're going to add to it this a letter. The a is the stretch factor. The stretch factor tells us how the shape of the parabola has changed. Now, if I am comparing, I always compare to that parent function, the x squared. So when I add the 2 or the 4 here, I'm comparing it to the original. The red parabola in my picture stays the same in all of these. It looks like it gets stretched out, but really you can see that the numbering is much higher in order to accommodate the steeper parabolas. So when I have 2x squared, as in this second picture, what we're doing is when we go over 1, instead of going up 1, as in our parent function, we have to go up double that. That's the 2 is multiplying the result of the x squared. So instead of going over 1 and up 1, we're going over 1 and up 2. But when we go over 2, we're not going up 4, we have to go up double that. So your point ends up all the way up at 8. This is the easiest way to remember how to graph, is just memorizing the pattern. If you can get these 5 points and think about how they might have been modified by that stretch factor, you can graph pretty much anything that I will give you in this unit once you know where this turning point is. Now, 4x squared does the same thing. I go over 1, and instead of going up 1, I'm going to go up 4. And instead of going over 2 and up 4, 4 times 4 takes me all the way up to 16. So you can see how the stretch factor makes it much skinnier and much closer to the y-axis as well. What if I didn't want it to be skinnier? What if I wanted it to be more flat or wider or closer to the x-axis? Well, you can do the same thing with the stretch factor by using a fraction. So a fraction will cause it to be wider. So instead of going over 1 and up 1, I'm going over 1 and up a half. Instead of going over 2 and up 4, I'm going up half of 4, which is just 2. And so with the 1/2 stretch factor, I get a wider parabola. Now, we can turn our parabolas kind of like you can take a line. A line can either be positive or negative. In this case, we have either parabolas that go upwards, like a smiley face, or they point downwards, like a frowny face. If they open upwards, your A is positive, and if they open downwards, A must be negative. Other than that fact of flipping it upside down, the stretch factor does exactly the same pattern. So here, the purple is a -2, So I go over 1 and down 2. Over 2, down 8. Remember, that's double the 4. So the pattern of the number itself stays exactly the same no matter what the orientation is. Now, in our lesson in class, we're going to be using this concept, but we need to know a little bit more. We don't just want to be working with parabolas that are stuck at 0, 0. So in order to move the parabola to a different location on the coordinate plane, we're going to use what's called vertex form. Vertex form in the general is this formula, a little explanation here. H comma k is the vertex. And you might remember this from circles. H comma k was also the center of the circle. This is kind of like that in that the vertex is the most important point. It's that turning point that tells us where the U, or the bottom of the U shape, is. In this case, we have the parentheses. And you might notice that here we have a minus inside and a plus outside. This is probably the most confusing part of using the vertex form. When you want to plug your vertex number in to write the actual equation, or you want to pull it out to graph, you have to keep in mind that that minus inside of the parentheses causes the sign to change. But the plus outside does not. So it only happens to the x value. So let's look at this example. Write the equation of a parabola with a stretch factor of -2 and a vertex at -1, 3. So the -1 is going to go where that h was, and the 3 goes where the k was. Notice how the -1 also has the minus in front of it. Minus a negative turns into a plus. But the +3 on the outside, because it's not inside those parentheses and it just has a plus sign in front, does not need to change signs. It stays the same. So inside parentheses, change signs. Outside parentheses stays the same. See you in class.